Hello grade 9s, welcome to today's Maths Lit lesson. I hope you all are well. I was accused by my grade 7 natural science class of being a little bit too robotic in my presentations, like the maths robot kind of thing. But yeah man, I'll try and make things a little more lively, a little more interesting. It's a little bit tricky to do that because there's no live audience and it's just my own voice echoing back to me in here. But yeah, anyways, let's try and see. So I sent you guys out some homework on the 18th, and that was to deal with perimeters and areas of quite simple shapes. So just triangles, squares, and circles. So some of you sent me some homework, and I'm pretty sure you got it right and everything, and your final answers will be correct. But I just want to go through this so that you guys can see the methods that I'm using. So yeah, just to get that comfortable with that. So the methods are really important because if you can establish them for the simpler examples, then you can repeat them when we do more complicated ones. Okay, so let's look at the first question. This was exercise 9.2 on the colored page. Before we start, I'll just put the heading. Homework solutions 18 May. So the first question is a scale problem. Recall that there are 10 millimeters in 1 centimeter and that 1 centimeter squared covers the same area as 100 millimeters squared. Okay, so before we jump into that problem, I just want to show you how they get that. Okay, so firstly, we've got 10 millimeters in 1 centimeter. And then if we have this 1 centimeter by 1 centimeter block, we can say now our area for a square is 1 centimeter times 1 centimeter. That will be the same as 1 centimeter squared. 1 times 1 is 1, and centimeter times centimeter is centimeter squared. So you can almost treat the unit a bit like a number. So for example, anything times itself is squared. So 4 times 4 is 4 squared. 2 times 2 is 2 squared. And centimeter times centimeter is centimeter squared. Okay. Now I'm going to do a little conversion. For 1 centimeter, I'm going to put 10 millimeters. So for this, I'm going to put 10. And then for the other one, I've also got to put 10. So now if we deal with the numbers, we've got 10 times 10, which is 100, and millimeter times millimeter, which is millimeter squared. So that's how they get this, this scaling from 1 centimeter by 1 centimeter to 100 millimeters. So this is now asking, it's saying a rectangle with an area of 24 centimeters squared has length 60 millimeters. Calculate the width of the rectangle in millimeters. Okay, so funnily enough, I don't think this is actually going to relate to the problem. But let's see. Okay, so once again, I'm going to draw a little picture to try and unpack this. Okay, our rectangle is here. That's the first piece of information, the type of shape. Then we've got our area that's given to us as 24 centimeters squared. And our conversion to millimeters, if it's 1 centimeter squared equals 100 millimeters squared, then 24 centimeters squared will be the same. So we're timesing the 1 by 24 on this side, and then we have to times the 100 by 24. So it will be 2400 millimeters squared. Okay, 2400 millimeters squared. And they tell us that the length is 60 millimeters. So this side here is unknown. So what this problem boils down to is that the length of this side times by 60. So length times height is going to be 2400. So the value of this side has to be 2400 divided by 60, and that will give us 40 millimeters. Okay, so I'm going to write that down in red. And you guys can just check it on your calculator. Check that when we get the area of this rectangle now. 40 times 60 is 2400. Okay, moving on swiftly to question 2. It says calculate the height of a triangle with base length 5,2 centimeters and area equal to 26,58 centimeters. And it also asks us to round off the answer to 2 decimal places. So this problem is similar to the first problem, and I'm going to deal with it in a similar way. So the first step is to draw a triangle. Any triangle will do, obtuse, acute, right angle, it doesn't matter. So triangle, our height, don't forget the height is at 90 degrees to the base. We've got the base as 5,2 centimeters. And the only other piece of information we have is the area equals to 26,58 centimeters squared. And they want us to find the value of the height. So the value of the height is unknown. I'm just going to call it letter H. So our formula for area of triangle goes 1/2 times base times height. You guys should be quite familiar with it by now. And what I'm going to do is, in previous problems, what we've done is we found the area given the base and the height. But these two problems, question 1 and question 2, flip the script. We're given the area and one of the sides, and then we have to work out the other one. So for area, I'm going to write 1/2 times base times height, and that must equal to 26,58. So I'm not putting down the units just yet. When I've solved everything, I'll put in the centimeters. So our base is 5,2, so we've got 1/2 times 5,2 times height is 26,58. So 1/2 times 5,2 is 2,6. So now we have 2,6 times h is 26,58. So how do we solve for h? Okay, we've got this number times the unknown equals this number. Let's look at a simpler example, and maybe my next step will make sense. So if we have 2 times h equals 4, and we're trying to find the value of h, you might instantly be able to see that h must be 2, because 2 times 2 is 4. Okay? And if you were to do a calculation, you would say h is the number 4 divided by 2. So it's this one divided by this one. Okay? Same story if we have something like 6 times h equals to 24. So you might be able to instantly see that h must be 4, because 6 times 4 is 24. And if we were to try and work it out using using the equation, we put that it's this number divided by this number. So it's 24 over 6, which is 4. So we're going to do the same thing over here. We're going to say that h is this number divided by this number. So it's 26,58 divided by 2,6. And I get 10,22. Remember, we must keep it to 2 decimal places, and our unit is centimeters. And pause. Now on to question 3. We have the shapes drawn for us already, and it asks us to calculate the area of each of these polygons. So these should be really familiar to you guys. We just plug and play into our recipes. So for 3a we have this red triangle, and it's an obtuse triangle. So an obtuse triangle looks like this, remember, with this angle greater than 90, and the height goes from here, and our base, it doesn't touch our base, so we have to extend our base by this imaginary line, and then we get this height at 90 degrees. So you can think of like if you have an awning or an overhang, and you try and measure the height, you don't measure this side over here, that doesn't give us height. It has to go from this tip directly down. Okay, so our values here are 11 and 24. I'll just fill it in while it's already there. 11 millimeters, 24 millimeters. And our formula for area goes a half times base times height, and that would be a half times base, which is 24, times height, which is 11. Half times 24 is 12, times 11 should be 131. 132. Sure, getting old. And don't forget our unit millimeters squared. Next question, we have a square. Okay, how do we know it's a square? Why can't it be a rectangle? Okay, firstly, you can see that it looks squarish. Okay, but the labels, the specific labels tell us the 4 sides are equal and the 4 corners are 90 degrees. For a rectangle, if it was a rectangle, they would have this side and this side equal, and this side and this side equal, but all 4 of them are not equal. And we have one of the edges as 15 millimeters. So now we know the values of the remaining sides. They must all be 15. So I'll just fill it in, one other side, 15. And our area equals to, it's the same formula as that for a rectangle. It's equal to base times height, but the value of the base and the height are the same. They're both 15. So it's equal to 15 squared, which should be 225. 15 squared, yes, 225, and our unit is millimeters squared. Okay, so for a square, you can think of the area as a side square, so 15 squared. Next, we have this green triangle. This is an acute angle triangle. So if you remember, obtuse was like, there's an English word for it as well. If somebody's being obtuse, they're being difficult. So you can see with this picture the height, we have to now extend the base, and it's a bit difficult. And the acute angle triangle is a lot cuter and easier to work with, in a sense that all of these angles are acute angles, so less than 90, and our height is quite easy. It falls within the triangle, touches the base. So we have a height of 7 centimeters and a base of 12 centimeters. And our formula, I'm not even going to write it again, I'm just going to fill in the values. So it's a half times 12 times 7, which is 6 times 7, and I get 42 centimeters squared. Okay, question 4. Calculate the area of each of these polygons. So what is a polygon, guys? Are we here to learn English or maths? A polygon is just a shape with straight sides. So this 5-sided shape, pentagon, can be a polygon, a square can be a polygon, a triangle can be a polygon, a circle can't be a polygon. Okay, so polygons always have straight sides. First question, 4a. We have a triangle, but the triangle is drawn like this. Okay, so what we can do is turn this shape around. So it looks like this. And now our base is here and our height is here. So to do this kind of thing, all we have to look out for is the 90-degree side. And the side, this will be our height then relative to the base. So the area here is a half times base times height, and once we flipped it around, our base is 10 and our height is 6. So it's a half times 10 times 6, which is 5 times 6, which is 30. No units in this problem. Now they have one other side here, and 8. So that's 8, 10, and 6. 8, 10, and 6. So that 8 is a red herring. It's not involved in any of the area calculations. Okay, next question, 4b. So 4b is another case where we have to split this shape up into shapes we can work with. So remember, the triangle, circle, and square are like our building blocks, and then we can make up these compound shapes. This shape in particular has the name trapezium. These two sides are 90. This side is 7. This side is 4. This side is 4. And this side is 5. So what I'm going to do is split it into a triangle and a square. So if this side is 7, and I've drawn this line directly down, then this side and this side are going to be the same. So it'll be 4 and 4. Let me write it in another color. 4 and 4. And this side will be the same, so it's also 4. And then if this length is 4, this missing piece needs to be 3. So we've got 3 plus 4 is 7. Also, because I've drawn this side directly down, it's going to be vertical at 90 degrees. So I'm going to calculate the area of the triangle, and then the area of the square, and I'm going to add them together, and I'll get the total area for this shape. Area of triangle equals to a half times base times height. The value of our base is 3, and our height is 4. So we get 2 times 3, which is 6. The area of the square equals base times height, so it's going to be 4 times 4, which is 4 squared, times 16. And the total area, which I'm going to denote by the letter A, equals to the sum of the two areas, the area of the triangle plus the area of the square. And let's fill in the values. Area of triangle is 6 plus area of square is 16, giving us a final answer of 22. So these videos took a little while, and this is just the first page. So I'm going to do another video on the second page of the homework.